Welcome to the DIY Honda Garage channel. The code P24B8 refers to an issue with the EVAP Leak Check Module absolute pressure sensor, specifically signaling that the sensor is out of the expected range. The EVAP system plays a critical role in preventing fuel vapors from escaping into the atmosphere. It does this by utilizing a leak check module that monitors the absolute pressure within a certain specification. Commonly located near the engine bay, this component interfaces with the powertrain control module, PCM, and other crucial sensors. If P24B8 is stored alone, begin troubleshooting specific to this code. However, should you encounter it alongside codes P24BA or P24BB, prioritize diagnosing and resolving those first, as specified in the diagnostic protocol. Remember, operational verification and a thorough understanding of the system's normal parameters are vital before any repairs are attempted. The EVAP Leak Check Module is essential for maintaining the integrity of the EVAP system by detecting leaks in the fuel system and ensuring that fuel vapors are contained. Specifically, the absolute pressure sensor within this module measures the atmospheric pressure as well as the vacuum created during a leak check. Ideally, it should provide readings within a specific range to verify that no leaks exist. The location of the EVAP Leak Check Module is generally found in the engine bay, closely tied to other components related to the fuel and exhaust systems. Its signaling to the PCM indicates whether or not the system is functioning properly, and any deviation prompts a trouble code like P24B8. Having a full understanding of how this component works is critical in diagnosing why the sensor is registering out of range. When diagnosing the P24B8 code, several potential causes must be examined. First, the fault might lie within the EVAP Leak Check Module itself, which could be malfunctioning or damaged and needs replacement. Second, it's crucial to scrutinize the connections to both the EVAP module and the PCM. Loosely connected terminals or corroded wires can certainly lead to erroneous readings. Moreover, wiring issues, such as open circuits or short circuits between the connector pins, may also cause the sensor to operate incorrectly. Each of these components must be evaluated systematically to ascertain the root cause of the issue and proceed with repairs effectively. The symptoms associated with the P24B8 code typically include the illumination of the check engine light, CEL, which serves as the vehicle's alert system for various issues. Owners may notice a decline in fuel economy, as a malfunctioning EVAP system can disrupt the engine's overall efficiency. Additionally, a vehicle diagnosed with this trouble code may fail emissions testing, as a properly functioning EVAP system is crucial for reducing harmful emissions. Drivers should be vigilant for any unusual performance changes or warning lights on the dashboard, as these early indicators could signal the underlying problem associated with this diagnostic trouble code. In the first troubleshooting step for a P24B8 code, it is essential to verify the problem using the Honda Diagnostics System, HDS. Start by turning the vehicle to the on position without starting the engine, which activates the onboard diagnostic system. Following this, clear the DTC from the system using the HDS to ensure that any previous codes do not interfere with the new diagnostic process. After clearing, turn the vehicle to the off/lock position before turning it back on again. This ensures a fresh read of any current issues present, allowing for an accurate assessment of the vehicle's condition before digging deeper into the troubleshooting steps. In the second step, it is crucial to check for any pending or confirmed DTCs stored in the system using the HDS. This provides insight into whether the P24B8 code remains active or is interspersed with other related codes. If P24B8 is indicated, it means the failure has been duplicated, prompting further diagnosis. Conversely, if it is not indicated, there may be an intermittent failure. In this case, it's important to inspect the connections to the EVAP Leak Check Module and the PCM for loose or corroded terminals. If previously recorded snapshots are available, try to replicate the conditions under which the failure occurred. This diagnostic strategy will help in isolating the problem accurately. In this step, we will determine the potential failure area within the circuit. First, switch the vehicle to the off mode to ensure safety when working with electronic components. Next, disconnect the EVAP Leak Check Module 8P connector from the module. This will allow you to further assess the voltage levels needed for diagnostic checks. After disconnecting, switch the vehicle back to the on mode to facilitate the measuring of voltage between designated test points in order to assess the functionality of the module. Follow through with the subsequent testing process to see whether the voltage output meets the expected values. In this step, we focus on checking the voltage between specific test points within the EVAP Leak Check module. With the EVAP connector disconnected, measure the voltage between test points identified at the connector's female terminals, specifically number 6 and number 8. With the vehicle in the on mode, ascertain whether the supply voltage reads around 5.0 volts. If indeed it does, this indicates that the power circuit is functional, allowing you to proceed to further diagnostics. Should the reading be inadequate, it implies a failure in the wire harness or connection, necessitating further inspection and repair in that area of the circuit. The fifth step involves checking the functionality of the absolute pressure sensor. To execute this step, first, turn the vehicle to the off lock position and use a jumper wire to connect Terminal A and Terminal B on the EVAP Leak Check Module 8P connector. Once connected, switch the vehicle back to the on mode and access the HDS to check the readings of the pressure sensor. Specifically, we want to see whether the absolute pressure reading exceeds 896 millimeters Mg. If it does, then indicate that the sensor is performing as expected, thus leading towards a resolution. However, if the sensor does not provide a reading beyond this threshold, be prepared for replacing the EVAP Leak Check module to remedy the issue. This sixth troubleshooting step focuses on checking the VCC6 wire for continuity. To do this, switch the vehicle off and utilize the HDS to jump the SCS Service Check System line, allowing for a more stabilized measurement. After waiting over a minute, disconnect the PCN connector E, ADP. Resistance should now be measured between the specified test points 1 and 2 within the disconnected connectors. The vehicle should ideally indicate a resistance of 1.0 ohm or less. If resistance exceeds this value, the implication is that there is an open circuit issue somewhere within the VCC6 wire, which will need repairs. Hence, this step lays the foundation for ensuring robust electrical connectivity. In the seventh step of troubleshooting for the P24B8 code, we check the SG6 wire for resistance to confirm its integrity. With both the EVAP Leak Check Module 8T connector and the PCM connector E, ADP, disconnected, resistive measurements should be taken between specific test points as previously outlined. A reading of 1.0 ohm or less indicates that the SG6 wire is functioning correctly. If the reading is above this threshold, it signifies an open circuit somewhere along the SG6 wire running between the PCM and the EVAP Leak Check Module, requiring remedial action. This step underscores the importance of ensuring proper electrical pathways throughout the vehicle's wiring system. During the eighth troubleshooting step, it is crucial to verify the integrity of the ELCM-PA wire. The process begins by switching the vehicle to the off lock mode and performing a jump on the SCS line. After waiting for over a minute, disconnect the PCM connector A, 50P. You will measure the resistance between designated test points while ensuring the EVAP Leak Check Module 8P connector remains disconnected. The expected reading should be 1 megaohm or more, indicating that there are no shorts to ground. Should the reading fall below this, it means a short exists in the ELCMPA wire, requiring appropriate corrective action like replacing the wiring or checking for other faults. In the final step for troubleshooting the P24B8 diagnostic code, we will conduct a thorough open wire check of the ELCMPA line. First, ensure the vehicle is turned off and remove the previously connected jumper wire from the EVAP Leak Check Module 8P connector. Then, jump the SCS line with the HDS and wait over a minute for accurate readings. Proceed to disconnect the PCM connector A, 50P, for testing, measuring the resistance between the specified test points outlined for this step. A reading of 1 ohm or less confirms the integrity of the ELCMPA wire. Should any abnormalities arise from your readings, it will warrant corrective action, such as identifying and repairing any open circuits within that wire. After implementing necessary repairs and replacing components, the final step involves verifying that the issue has been resolved. Start by clearing all diagnostic trouble codes, DTCs, using the HDS, effectively resetting the vehicle's onboard diagnostics. Following this, perform a road test under normal driving conditions to ensure the vehicle operates without triggering the previously encountered DTC P24B8. Monitor the system for any signs of abnormal operations or warning lights, as this step confirms the effectiveness of the repairs made. A successful road test and the absence of the code would verify that the repairs conducted were indeed effective and that the vehicle is back to optimal performance. To prevent future occurrences of the P24B8 trouble code, consider implementing a regular preventive maintenance routine focusing on the EVAP system. Schedule periodic checks of the absolute pressure sensor to ensure it's functioning within expected parameters. Also, inspect wiring connections throughout the entire EVAP system periodically to address any signs of wear, corrosion, or potential loose terminals. Software updates from Honda could also enhance the accuracy of diagnostic systems, keeping the vehicle performance optimal. Strengthening these maintenance protocols helps in filtering out minor issues before they escalate into severe complications that could lead to costly repairs or replacements. In conclusion, dealing with the P24B8 diagnostic trouble code requires a systematic approach to diagnosis and repair. Understanding the various components involved in the EVAP Leak Check Module is essential to identify and rectify the problems effectively. By following the detailed troubleshooting steps, you can uncover the underlying issues, ranging from faulty sensors to wire integrity problems. Repairing these issues accurately is crucial in restoring the vehicle's functionality and compliance with emission standards. Moreover, maintaining a regular schedule of preventive checks enables the detection of possible signs of problems early on, safeguarding against unexpected failures and ensuring long-term reliability of the vehicle. Please like and subscribe to the channel. See you next time.